If you have ever built a word search from scratch, you know the structural constraints. Hiding words, padding the remaining space with random letters, and ensuring nothing accidentally overlaps by hand takes massive amounts of time. A dedicated digital generator automates that process. It uses an algorithm to instantly calculate the matrix and translate a raw vocabulary list into a playable layout. The prerequisites for this are minimal: a stable browser connection and a curated dataset of 10 to 15 topical words. For this example, we will use a list of solar system terminology. The objective is to run that data through the system to produce a scalable, print-ready educational asset, fully equipped with a verification key. Offloading the architectural layout of a worksheet means you spend less time on tedious formatting and retain your focus on the actual pedagogy. Step 1 is navigating to the MiniWebTool word search generator interface and locating the primary text input zone. This diagram shows the formatting protocol for compound terms. You must remove the spaces between words. The grid generates continuous character blocks, so a term like Milky Way needs to be entered as a single unbroken string. With that rule applied, you simply paste your curated space-themed dataset into the text box. Next, we establish the grid dimensions. The architecture here is highly flexible, supporting anything from a compact 8x8 square up to a dense 25x25 matrix. Selecting a matrix size smaller than your longest input string breaks the algorithm. A 10-letter word physically cannot fit inside an 8x8 framework. To prevent this, calculate your longest string and expand the grid threshold to a comfortable 15x15 matrix. Anticipating spatial limits ensures the system successfully processes your entire vocabulary list without rejecting any terms. We control how the algorithm hides our text using 4 directional vector settings: horizontal, vertical, diagonal, and reverse. Diagonal and reverse placements require advanced pattern recognition, which introduces a high cognitive load that often frustrates younger readers. As this diagram demonstrates, disabling those diagonal vectors and isolating the vertical and horizontal paths systematically lowers the difficulty ceiling for elementary-level tasks. Activating all 4 directions accomplishes the opposite, generating a complex challenge suited for an advanced demographic. Beyond structure, the interface provides aesthetic parameters to customize the visual theme of the final output. Selecting a dark blue and purple color scheme creates direct thematic coherence with our space vocabulary dataset. Manipulating these directional rules and color variables calibrates the tool precisely to your specific audience's capabilities. With the spatial and difficulty parameters locked in, trigger the final generation sequence. The interface populates instantly, confirming that the spatial algorithm successfully distributed our vocabulary evenly across the 15x15 board. This animation shows the live verification process. You can test the interactivity right in the browser by clicking and dragging across a target string like Galaxy to ensure the logic holds up. To extract the asset, navigate to the Print Preview rendering. The system strips away all the UI clutter and website navigation, yielding a clean, high-contrast physical worksheet. Directly below the primary layout, you will find an automated answer key that the system generates simultaneously. This map functions as a critical verification layer, removing the need for an educator to manually solve the puzzle before grading student submissions. Transforming a raw list of text into a highly calibrated, instantly verifiable educational instrument demonstrates the precise leverage gained from targeted digital tools.